A weakness of the Bohr model is that Bohr just stated, without an explanation, that an electron in an allowed orbit did not radiate. Physicists, and frankly people in general, like to have explanations. De Broglie's wave theory of matter explained it very well. As long as the circumference of an orbit, okay, so we have the orbit, we all know what a circumference is, it's just the, well, if that were a circle, there's your circumference. As long as that's an integral multiple, and again, that's a recurring theme in quantum mechanics, this integer multiple of different functions of different constants. So as long as that circumference was an integral multiple of the de Broglie wavelength of an electron in that orbit, it would not radiate. This approach yields the same relation that Bohr had proposed. In addition, it makes it a little more reasonable that the electrons do not radiate as one would expect otherwise from an accelerating charge. These are circular standing waves for various different orbits. Over here you have n equal 2, and you can see it kind of has two lobes here, n equal 3 and n equal 5. As long as the circumference of the orbit matches an integral number of these de Broglie wavelengths of the electron, it would not radiate. And this also explains why its angular momentum is quantized. Now, if you recall a standing wave from wave theory, it's when a wave hits a wall, reflects back, and then the wave doesn't travel anymore. It just kind of stays stationary and vibrates up and down. That's kind of what we're getting here. Now, obviously, it's way more complex than this, but the important fact to remember is the circumference of the orbit matches an integral number of the electron's de Broglie wavelength.